Okay, so we are going to be working on, again, this one is on how to write empirical formulas. It is going to be 133.87. Okay, so that's what we're going to be working on real quick. So I'm only probably going to do one of these just because of time. They do take a little bit. We'll see what the time goes, and maybe two of them. But let's just go ahead and get started. So the first thing that we're going to need to do, your first step, when you're doing the empirical formula, is always take each of your grams and go to moles, because we're going to be doing what's called a mole ratio, is what we're going to be looking at in order to find the subscripts. Okay. If you read through earlier on your packet, your book, let's say you have something like this. And so that means, let's just talk about what it means. It means you have 1 mole of carbon for 1 mole of carbon tetrachloride. That's what that means. Or you might say that you have 1 mole, 4 moles, sorry, we'll go that one, 4 moles of chlorine for 1 mole of carbon tetrachloride. And so that's the kind of the part that we're looking for. Or we might say we have 1 mole of carbon for every 4 moles of chlorine. And so what we're going to be doing here is finding this ratio. That's what we're looking for, is that ratio. So in this case, for carbon tetrachloride, it's a 1:4. So what we need to do is figure out what it is for this silver and oxygen. So we're going to first take, our first step is to take our grams of silver and convert it to moles. Sorry, I put aluminum. 1 mole of silver. And go to your periodic table, find silver. So silver, 107.8682 on my table. Okay, so that's going to get us to moles. Grams cancels with grams. I now have moles of silver. So we're going to compute that. And I get 0.015. And now I've got 4 digits, so I'm going to go ahead and hang on to things. 3, 1. So that gives me the 5 that I have. So I have 4 that I have. I have 4 here. I have 4 here. Okay. Get you a label on that. This is moles of silver. Okay. Don't leave your label off. So we have transferred this now to moles of silver. So we've got the top part here. Now let's do it with the oxygen. 0.1224 grams of oxygen. And so 1 mole of oxygen. And again, go to your table. Mine says 15.9994 grams of oxygen. Okay, my grams of oxygen are going to cancel. We're going to run the numbers real quick. And our answer is, I'm going to go ahead and put it in decimal form. My calculator put it in scientific notation. So let's see, -3. 1, 2, 3, 6, 5, 0 moles of oxygen. Okay, so we have changed both of these to moles. And so now we're kind of getting ready to figure out our mole ratio. Guys, please do not come back in and just divide. This problem is done. We're ready for the next step. So this is step 1. Okay, this is step 1. So now step 2 is you're going to divide by the smallest. So I'm going to do my silver and my oxygen. My silver is 0.0153, okay, moles. My oxygen is 0.007650 moles, okay? And then I divide by the smallest, okay? So I'm going to divide by the smallest here, and 0.007 is the smaller. So 0.007650, got moles, 0.00765 moles on that. And then we can do our division. So 0.01531 divided by 0.007650. And this comes pretty much out to exactly 2.0013. So I'm going to call it 2. Okay, and then of course we know this is 1. Okay, so now this becomes my mole ratio. My mole ratio. So I have Ag2O, and it's a 1. This is then my empirical formula. Okay, empirical formula. Now, this is not the molecular formula. So if you're needing molecular formula, that's going to take one more step. Okay, but these would be the steps that you would go through. Okay, so you do need to rewrite step 2. Do not put the division up here because then you have a mathematically incorrect statement.